Hi, so we'll get it started.
Sure, Hussein, we can start now.
Okay, thank you. So were you all able to see my screen? Someone can confirm in the chat.
Yes.
Yeah, okay, thank you. So this session is for Analytic Zoo, a unified platform for your AI needs and all. So I'm Udayan, myself Udayan Manwalan, and Niranjan are going to host the session. So yeah, we'll straightly jump into the agenda of the session. So
Yes, hello everyone. Yeah, welcome.
yeah, he's Niranjan. Yeah. So we'll first see what is an analytic zoo, the introduction to zoo and its features, and need analytic zoo, and a small demo on how it perform for the DS and DE needs. So this is the architectural landscape analytic zoo. So analytic zoo is, it's a unified platform that gives us a analysis and AI conveniently together. So this is built on top of Spark, TensorFlow, Keras, and BigDL. So I'll explain each of the components like play a role in here, and it supports the kind of a style of programming. So as you might have seen in the Spark ML lib and scikit-learn, so it support that nature of building pipelines and all. So it supports many data wrangling and analysis using PySpark and all. And of course, like it supports the model development, and it has a wide range of built-in models. So as you see in the screen, the recommendation time series and computation NLP. So I'll explain further on exactly which model is as a built-in. So as part of ML workflow, so they auto ML. This is literally from a data to an deployment. So a complete process will be achieved through AutoML. And again, the cluster serving and model serving. We'll be covering these topics in the upcoming slides. And it gives us an integrated platform of AI pipelines as well the deep learning frameworks. Let's say a TensorFlow with a PyTorch on Spark will give you what you need. So TensorFlow serving you can run like TensorFlow models, and you can use TensorFlow modules, and PyTorch for the other data process needs. And each of the iteration of it learn will be on Spark. So I'll explain further. So if you're running a training on a very large amount of data, so each iteration of a training runs on a Spark job. So this gives us an achieved the same learning is achieved with a less time because it's going to learn in a distributed manner. So that's how all the process of work. So let it be a feature engineering, or you want to apply some models to an existing data, huge amount of data. This is how it's going to convert. So each job, each Spark job, a task runs as a same model on a subset of a data. So for each batch, so it will run as a parallelism. So three key points here is each, the process is a Spark job and it's iterative heavily. So so each has a dedicated Spark job for do a job, and it is parallel. So that's all about how we process the machine learning models and things. And this is an overview, just a brief of each feature. So first one is a end-to-end pipeline for applying AI models to a distributed big data. So we might have already heard about TensorFlow, PyTorch, and OpenVINO. So these are the frameworks that provides end-to-end pipeline for a AI model. So big deal, Analytic Zoo, you can unify the power of each platforms here. So that's one advantage of Analytic Zoo. And cluster serving, so we have a problem statements explained out of this feature. So cluster serving is for automatically distributed model inferences. So you might have the models that may need your, I mean, for your application development, you may need some model and it has to be hosted on somewhere to get the inferences and all. So this requires a high cost GPU machine for learning, and of course like a large amount of data to be stored, and that's going to take another cost. So, so the cluster serving with analytic zoo, like since it's going to, I mean, do the things in a distributed manner, the cost and time is low, and this is a gift for a data scientist and data engineers who is frequently like playing around with model inferences. If you want to add or remove a layer, and if you want to train a particular neural layer, so those flexibility it gives over the data on the models. So it provides the scalable auto ML. So there will be a task executors and managers. So they will take care of the how many clusters they have to spin and all. So this automatically it can scale. So even the cluster serving is automatically distributed, I mean, evenly. So in addition to that, they provide built-in models. We will see this on further, and high-level ML workflow. I'll give you the sample of how a ML workflow looks and all. So this is the overview of its feature, one level deeper. So NN frame. Let's go to the NN frames. So NN frames is a easy to use data frame based API for training and prediction and evaluation of model and all. So when it comes to the big data, so we need some packages that are built already to handle the huge amount of data, right? So this I mean, by default will take care of how a huge amount of data, let it be audio or text or numbers, it's been handled. So it offers a 4 classes. So NN estimators, NN model and classifier, and NN image reader and all. These are subclasses I didn't mention here in the slides. So if you can go further and see, like, it will be really helpful when it comes to the pre-process with a big amount of data. So AutoGrad, it AutoGrad, and it has a, I mean, auto differentiation operation as well. So these are come as a API itself. So you don't need to train your own model. Even if you don't have a models, like they have, you can reuse any of the built-in models that are provided here, and playing around these features like transfer learning, model serving, and AutoGrad and inference. So transfer learning like enable us to like customize the pre-trained model for the feature extraction, and if you are doing some hyperparameter tuning, and if you are adding something to an pre-trained model. So of course you don't want to reinvent the wheel, you don't want to start from the scratch. So you can use the already pre-trained models and you can develop on top of it as per your need. So let's say if you are working on a CNN problem, so you can use the already available object detection API. So okay, so which will by default will take care of the capabilities of dealing with a huge images data. And if you want to reshape the huge amount of data, so it's not going to take much time with these available packages. So let it be okay, so it has a feature image package dedicatedly Analytic Zoo has, which will allow you to resize or improve and brightness of your sample images, and the other features also. So yeah, maybe if you go to the documentation page, like you will get a better clarity. So as part of object detection API, it provides SSD and faster RCNN. So advantages with these APIs, right? So these models are trained in a distributed fashion. So you might have compare with normally trained ITER's GPU machine trained model, and with this, like of course, with a huge amount of data, you can compare evidently the advantage of distributedly trained models. So that you have to experiment and play around of it. And as part of image classification as well, like they provide mobile net and RESTnet models, and which really needs a very big amount of data to be trained on. And for the text classification, it can leverage on top of CNN model LSTM. So and the same for other recommendation API and anomaly detection and all. So for recommendation, neural collaborative filtering, and for anomaly, LSTM again. And these are newly introduced APIs like text matching API and sequence to sequence API. So when we used to deal with the NLP problem, this was the problem. So we don't have the NLPs. I mean, uh, we don't have that NLP with a API-rich ecosystem. So we may need a something like sequence to CPI. We was looking for that since we are working on the chatbots and all. So it's a kind of general purpose encoder decoder framework. So it can be used in the chatbot and machine translation and more. So yeah, this is of overview of features. So why we have to switch to analytic zoo? So obviously, like if you want to prototype, you want to easily prototype and complete pipeline that applies some AI models with already given stacks, TensorFlow, Keras, and PyTorch and BigDL, and you want to move that to the production. So not many of the deep learning frameworks gives the support for production. So although it's an open source, package, Analytic Zoo is an open source. So this gives us the production big data and the flexibilities over the model with the features it has. So if you want to transparently scale, so you don't need a rich ecosystem to at the development stage. You can train and test your model with a small quantity of data in your local node, and you can slowly deploy it to the heavily, performing clusters, K8 cluster, let it be K8 clusters and a Docker container. So you can scale that. And if you want to, if you have an already a rich ecosystem of Yarn or Hadoop, so you can, so some clients are like concerned about the data security and also they don't want to migrate to the cloud, and also like the data is huge for the entire migration. So they have to migrate everything to the cloud. Then they have to use some costly machines to train some models, and they have to integrate, they need a CI/CD pipelines, Jenkins pipelines to integrate as a process and all. So instead of that, you can configure on your local, cluster. If at all you have an already existing cluster, you can integrate Analytic Zoo on that, and to maintain the security of your data. So, and again, like all these are a process. So let's say for feature engineering, you use some framework. Let it be Spark. So for hyperparameter tuning, you use some other. So everything comes in a place in here, Analytic Zoo. So even for feature engineering, hyperparameter tuning, selecting a models. So even if you have a own model that are trained, you can use that. So that flexibility it gives. So you can automate the process with the already provided stacks. So I'll explain further of the flow, how the complete flow is coming, and you can give that model outputs as a distributed inference. Yeah. So we'll see some real world deep learning challenges that Analytic Zoo solves. So you might have already known this uh, diagram of Andrew Ng. So in his deep learning course. So most of the deep learning models requires data in high amount. So as you can evidently see, for the small training sets, the performance is very limited. So this is the reason deep learning needs to be big data and distributed fashion of learning and processing things. So again, like the feature engineering at a larger level, it's not easy with most of the tools that are running nowadays. Of course, like TensorFlow and the other tools have come up with their own serving methods and handling the things like how it deployed across the clusters and all. So yeah, so other problem I am seeing is like the models require a high cost GPU machine, as I already explained, because we suffered a lot in our experiences. So the high cost GPU machine, even for the development, we need a plenty of time and a high cost GPU machine to be trained on. And even if we made a one mistake, then it is going to take another 8 hours like for that. So yeah, it's time consuming. And yeah, the frequent changes we made through a deployed model, or some data need, some data reshape kind of things we want to do. So that needs an already set up the process. If you are in an initial stage and you don't have, I mean, you don't have any CI/CD pipelines already configured in place, this is going to be hectic for you. So yeah, that is one point. And most of the larger enterprises like prefer to maintain their data in their local clusters, as we already know. Like they already have a rich ecosystem. Just for a feature, they don't simply like migrate one. So the preferred cloud of their choice. So so they are looking for an open source package that scales out with their resources. So this will be a opt for them. So any data engineer or data scientist, they want to play around with a model. Let it be a like I mean supervised learning, and that model needs a manual intervention from you. So let it be a epoch adjustment, the learning rate at which it learns and all. And if you want to tune some parameters based on a previous model's inferences, so if you want to add and remove a layer to a neural network, so those kind of tasks will be easier when it comes to analytic zoo. So in a line of code, you can add a layer to a sequential model or any model for that matter. So this is one of the, I mean, maybe a brief of problem statement. So as deep learning projects evolve from experimentation to production, so there is an increasing demand. So to serve the deep learning models, this is a really problem statement for at a larger scale, because so if you have to offer a real-time distributed inference, like the setup is very huge. Though there are many tools available, so model optimization, serving for cluster scheduling and workflow management. So there are many tools available already. So it's again a challenging process for many deep learning engineers to develop and deploy in a distributed, I mean, deploy a distributed inference workflow that can automatically scale out to large clusters. So this is an point to this uh, analytic zoo, like it can scale out to the large clusters in a transparent fashion. So yeah, so this is a exact feature of cluster serving, how it deals the thing I'll explain. So again, we have seen that introduction of cluster serving. It's a lightweight and distributed real-time serving. So you can integrate with Apache Splink or Storm, so you can achieve that real-time serving of your model. And OpenVINO and BigDL are already a rich ecosystem, so that can sit on top of anything like PyTorch or TensorFlow, or your Spark code or your Spark ML lib that you already developed. So so it provides a two kind of APIs. So one is a simple PubSub API, which user can, I mean, send the inference request as an input and using a simple Python API, and you'll get the outputs in a JSON format itself. So yeah, we'll see how it is done in this diagram. Like the client, the third party, I mean, client is you, and with the Python, you're going to give some many request of, let's say, request. Will handle that in a queue request and get your model inferences asynchronously. So it support asynchronous request type. So let's say if for HTTP request, normal typical HTTP request, it's going to be a single request at a time. So as we already know, but with Python async API, we're going to deal it asynchronous manner. So multiple model inferences at a time. So this will be really helpful if you are dealing with some products and you want to show the inferences at a second. Like so once the price button clicked, then the prediction price should be displayed. So that kind of I mean use case. So I'll explain how the how as the request look like. So as we already see, it's a JSON format, and this is an example for the method to before we send to the your model. So yeah, it so another the PubSub async CPI you can achieve through the you can import as a package the zoo serving client import and all, and with an and array of requests that should go into the model and receive as a, I mean, the model output and all. So yeah, so that's it. Where in demo we'll see like um, how the LSTM like detect anomalies in a NYC passengers data set. It's a very minimal demo, and I'll show you how the cluster serving setup is done with a Docker container. So before jumping to the demo, like I'll wait for one minute for the Q&A. So is there any questions? Please use that raise hand option of Zoom, like if at all you have questions. Okay. So if you don't have any questions, like we'll go to the demo. So we have a very tiny data set with 10,000 records, numerical records, only 2 columns. So this is a code. This is a complete code that I mean train a model and give us the output as what is the anomaly from a given data set. I'll go line by line here. So for this Python script, we're going to give where the data reside as an input directory, and the batch size, like uh, how the batch it should take for learning and learning the model, and as well as epoch and unroll length. This is something related to the so anomalies detection. So if we give this as a this will be used in this for the model prediction and all. I don't want to dig deeper into how the model works and what are the log. I mean, uh, the feature engineering they are doing and the optimizers and loss their metrics and all they're doing and all. I just want to demonstrate how analytic zoo can help the things better. So yeah, so we are receiving those as a, I mean, input, and we are preparing the data set at this spot, and we have created that as a data frame, and this is they're doing some standard scaling for standardize the data to avoid there is some mismatch or null, all will be handled here, and those scaled data will be like sent to a model, and here they are importing a model simply as it like zoo models anomaly detection import anomaly data. So that's it. So you can do all the anomaly detection related pre-process with this package itself. So if you are unrolling uh, uh, the data size, let's say if you are dealing with temperatures, so what is the buffer amount you can give? So it should vary. For a human, like 28-degree is fine, 29 is fine, but certainly 40 is not fine. So you have to give that limit of up to which level it should check and all. So that we are giving it here. So this will help in predict anomalies accurately. So only you will know as per your data's need. So yeah, they have so pause this model. This is the model code in one line. So they are giving the shape of the feature shape of the data and the hidden layers and the dropout functions and all, and the metrics and optimizer they are using for and all. So yeah, so that's it. So it's going to give us the predictions like this as a result here, result of this function. We're going to pass the actual numbers and the predicted and all. Yeah, we'll jump into the demo now. So I've already set up this system. Like this is the parameter. All of the other are optional parameter. We don't to send and all. So I'm giving the input path of the CSV file here, the NYC taxi dataset. So yeah. So this init context will prepare the BigDL configuration and all. So everything will run backgroundly. It will prepare and spark some submit argument. And it will expand the jars from a given path file. Typically, it won't take this time. Yeah, yeah, it has started the training stages. Like
One second, Udayan.
yeah,
Sam
yes,
wants to ask something.
okay. Yes, Sam, you can go ahead.
Yeah, then so can you show us the data set? Uh,
Okay,
you mentioned there are two columns, right? So
okay. So once this is done, like I'll show you the dataset.
yeah. And another question is like, have you implemented this in your project, or like, how did you like come across this? Like, what
So
was the problem you're facing, and and uh, how
yeah,
how did you think like this would be an a perfect solution for your case in your case?
yeah. So when we are like dealing with multiple problems, like the training a model in our local cluster was challenging. Like we needed a GPU machine. So we were finding ways like with the help of big data and its tools, like how we can learn in a distributed manner. So that was the intention behind choosing such big data packages. And even we are preparing MVC with cluster serving and all. So maybe in the series, like we'll cover that feature as well. Like, but to is that answer your question?
Yeah, and what was the problem you were trying to address? I mean, the project objective.
So okay. So in our case, it was an NLP problem. So we had the models, and we have a huge corpus of data from which the text classification model needs to be built and all. So that time, like we bought some GPU machines to, train I mean, get the outputs of it, and it took a lot of time. So that is no exact reason behind why it is being chosen, but uh, it's not solving a certain problem, but it can solve many problems. So we have recently only discovered these technologies. Right? We are in the interest of time, we are applying that now only. So we didn't happen to use this in our any of the projects. Yeah.
Yeah, understood. Yeah,
Yeah. Okay.
thank you.
Thank you. So as a result, like it provided the list of anomalies from the data set. So I didn't dig deeper into how it is anomaly and how it is vary from the data set and all. But this is just a demonstration of how Analytic Zoo can train a model in a second and give us the output simply in a Python objects. So it trained around 1,000 records in a batch in 0.5 seconds. So this is really a matter to me, and for anyone for that matter, if they want to learn. I mean, let's say, yeah, maybe this can answer you better, Vishwa. So for a CNN model for a object detection problem, I trained around 8 hours of my time to train a mobile net model. So even with if it is available with a big deal, so it will be done in maybe 2 hours in a distributed fashion of time. So that is the advantage I see here. You don't have to wait all the 8 hours to train your models and all. So with this setup of big data and Hadoop, or even in your local, it can learn distributely and pre-process also. So if time permits, like I'll show you like how the pre-process can be done with a, I mean, analytic zoo. Yeah. Okay. So any other questions?
Yeah, I have one. So this is awesome. So
Okay.
we have a similar, similar kind of problem, identifying the anomalies. So is there any reason, why you took 50%, or any research papers on that, how to fix the threshold?
Uh, what do you mean? Like here, where did I
Uh,
mention of 50% here?
Line number
uh,
71.
isn't it?
Okay, here.
Uh,
No,
yeah.
no. So this was the built-in reference use case code, like given from the analytics end. So I didn't dig deeper, like about the models and how it performed, like as I already told. So I
Okay.
just want to, I mean, track the metrics of how long it is taking for a learning and how long it is taking for pre-processing and all. So only that perspective I searched.
Cool, cool. Yeah.
Yeah, sorry. Okay. So any more questions? If no, like we'll jump into how the Docker thing is being set up. So this is,
To the end, let us show the data set to Sham then. He's asking us.
yeah, sorry. Yeah. Okay. So this is the time, I mean, data set. So it has a timestamp, and in that timestamp, how many count of passengers in the taxi. So yeah, not in a single taxi. So it's a data set, of course, like it has its own requirements. And they are doing some pre-processing here. So of converting, it should be, the working hours should be, I mean, greater than 6, and it should be less than 23 and all. They have some their own logic of defining what is awake and what is the daytime means and all. Yeah. So this is the data, Sam, for your reference.
Yeah, thank you. Got it.
Okay. So I'll show you like how the Docker thing is. I mean, let's jump back to the slide and it will give some context. So for the cluster serving, right? So we can achieve it through the, so in a Docker container, how we are going to set up our own model. Let's say if I have a model and I want that as a API, if this is your need, and then I'm going to show you how you are going to do it with the analytic zoo. Okay. So yeah, so this is the page. So you have to pull this an Intel Analytics slash cluster serving image from a Docker hub. So the command will be available in the section, or I'll show you. So this is the command for pulling the Docker image from Analytics view. And this way we are going to execute and get into the Docker container of what it contains and how we should point the data. data on the model. So now that we have come into the interactive shell of Docker, so this has a cluster serving folder in it. So with just this cluster serving start, it's going to give you the serving inferences of your model, model outputs and all. So before that, like we need a configuration of where the model resides and where the data resides and all, right? That we are dealing with this config file. Config.yaml. It's in a YAML format. So the path mentioned here is resources and model. So let's go to that first. So cd resources and model. So we have some inference graphs here. So if you have already worked in TensorFlow or Keras model development, so you'll have this inference file at last to be used for the production needs and all. So this is one of the frozen inference graph of an object detection model that is already trained. So we're going to just use that and show us show you the inferences. So, and yeah, we'll jump into that config again. So this is a path where the model resides and excuse me. Yeah, so we have the mode. We can specify the mode and the inputs for the TensorFlow models and all, if at all anything. And for the data, you can mention the source and all. If you have some databases and you can, let's say, if you're keeping your model on a database, like you can give that path of a database. And you can, most of the models need some pre-processing before loading into the model. Let's say if simpler reshape. So you can specify that your dimensions here like this. So this way you are defining the shape at which it should run and run and all. So in case if you want to see only one result, because some models will provide multiple results, so you want to specify the top one feature of it, then you can specify like this. And this is the core number of cores and performance mode and the additional parameters. And this particular sample going to use Redis as a backend and Flink Redis and Flink as a backend. So you can specify the maximum memory that Redis should use and all. And yeah, the Spark job parameters. So you can specify the driver and executor memory and the number of executor that's going to deal with it. You can customize as per your machine's need. Let's say if you have a highly performing machine, you can increase the parameters here, the total number of cores to be used and yeah. So we'll see what is this cluster serving code contains. So actually that is the setup. So if we run the cluster serving start, it's going to take some time and give the your model's output as a Python APIs. So yeah, so since we are working on this, like in the upcoming series of this, we'll show you a complete demo and MVC of how it is done. So I'm not going to like go by line and all. So this is just how it parses the config file, the configuration we specified, right? So it just parses that in this code, and it's going to set up the Redis and Spark home environments, and then it's going to unpack some BigDL jars and other things that are needed. It's going to all these are background, like just for our flexibility and customization. I'm explaining this. Like if you want to customize something, let's say if you want the Flink should be run parallel, you can add the parallelism factor here as a number, parallel numbers. So this will enable the Flink backend run as a parallel. So if at all you have the need to do such things, like this is the file you should go for. And yeah, so I'm not going to run this cluster soft now, as it's going to take at least 15 minutes. So that's it. So that's my demo. So if you have any question or feedbacks, like feel free to listen to you. Yeah. Thank you. Is there any questions from anyone?
Yeah, so Udayan,
Yeah,
which
yes, sir.
source did you refer to, like for this? Is this a Apache project or something like that? They have made in docs so that we can go through and like
Okay.
learn from.
Okay. Then yeah, I'll post a link in this group. So this will. So this is the official documentation link where you find all the things. Post that into the chat.
Yeah, got it. Thank you.
Yeah. Is there anything else, guys? Like, so any doubts on any problems?
Hey, this is Karthik here. This was excellent here. Really good presentation. Quick question is, so this can run on Windows also, right? It's the package.
Yes, yes. Can run on Windows with the help of Docker, and even it comes with a Python package and all. So definitely it can run on Windows.
Cool. Okay. Cool. And this is basically an Intel package, is it? They have kind of combined
Yes, yes.
multiple. Oh.
Yeah. Intel just open sourced this and BigDL packages. Yeah. BigDL and Analytics have been open sourced. Yeah. So thanks, Karthik, for the feedback. So anything else, guys?
Jayan, this is Govind here. It's really good, man. My question is with respect to the capabilities of Analytics Zoo. Does Analytics Zoo support any kind of APIs for SLAM algorithms?
SLAM algorithm. So what kind of problem it is? Can you be specific on what SLAM is used for?
Okay. Say I need to map a location. Say a particular. Let me give a scenario. A room is there. I need to identify from my particular location if I'm able to map the scenarios around me.
Okay.
SLAM stands for simultaneous localization and mapping. With the reference point of where I stand, if I'm able to move in the space, I should be able to find it out. If you would have researched on this, right?
Okay. Is it kind of an NLP problem, like how you're handling spam and ham?
Mm-hmm.
Yeah. So if that is the case, like they are providing the text classification APIs, you can go and explore on that perspective. Let's say text classification. There are some reference use cases already provided. So if you can explore on that, like you'll get an clear understanding. Yeah. Thanks, Govind, for the question. Yeah.
Thank you. Yeah.
So anyone else, like? We still have 3 minutes. 10 seconds, 10 minutes. Okay. So, so if there are no questions, we can wind up the session. So, thanks, guys. Thanks for attending this session.
Thank you.
Yes, thanks, people. Thanks for your time.
We'll post the recording of the session for your references. Yeah. Okay.
Sure.
Thank you. Bye-bye.
Thank you. Thank you.
Y'all.